Hi everyone. Today we're going to study limit of a function. On this topic, we need to define some terms. Number 1, variable. We say that variable is a letter or symbol that may assume any value. Examples are x, y, z. But the most commonly used variable is the x. And this x can assume the values like 5, -20, or 0, 100, 3/4, and any other real values that we can think of. Next thing to understand is the symbol x arrow a. X here is a variable and a is a constant. We read this as x approaches a. The variable x is coming closer and closer to a, but not necessarily mean equal to a. Example, x approaches 3. Let us draw a number line and identify the location of the number 3. And here it is. Now, let us consider those numbers that are coming closer and closer to 3. I'm not referring to the numbers 2 and 4, but those numbers that are really close to number 3. I'll put one example. 2.9. This 2.9 is close to number 3. I have another example, and that is 2.99. This number is closer to number 3 than 2.9. If I think of another number, I will write 2.999. This number is closer to number 3 than the two numbers mentioned before. I'm going to write 3 more examples, and the numbers are 2.99999, 2.99999, and 2.999999. I hope you can see a pattern on this. I can continually put more examples by following the pattern. Take note that these numbers are coming closer to that number 3 from the left side. Now, there are numbers that are coming to number 3 that will come from the right side. I'll put one example. 3.1. This number is close to number 3. I'll put another example, and that is 3.01. This 3.01 is closer to 3 than 3.1. Another example is 3.001. This 3.001 is closer to number 3 than the two numbers mentioned earlier. And I can put 3 more examples, and these are 3.0001, 3.00001, and 3.000001. I hope you can see a pattern, and we can put more examples following the pattern. Take note that this group of numbers are coming to number 3 from the right side. Now, the symbol x approaches 3, referring to the two groups of numbers that are coming to that constant 3. To be specific, for that group of numbers that are coming from the left side that comes to number 3, we're going to use this symbol, x approaches to 3 with an exponent negative sign, while the group of numbers that will come to number 3 from the right side, we will use the symbol x approaches 3 with exponent plus sign. Next term is the function. We had a 1 semester long period to discuss about a function. We learned this from the pre-calculus subject or pure math course. Let us write some examples of the function. I hope you still remember we have linear function, quadratic function, trigonometric function, logarithmic function, and all the other functions that we studied. The function is symbolized by f of x. Sometimes we have g of x or h of x. We are now ready to discuss the limit of a function. Let f of x be a function of x. If the values of f of x can be made as close as possible to capital L by making x close enough to a but not equal to a. It is denoted by lim f of x as x arrow a equals capital L. This expression is what we're going to see every now and then when we study calculus. We read this as the limit of the function f of x as x approaches a is capital L. Let us see example 1. Given the function f of x, the function is represented by this graph. We call this a piecewise function. This is the first piece. It is a straight line, and at the end is a hole. Another piece is like half of a parabola. It starts from here with a solid dot and it goes up. Another piece of the function is this graph that goes down. It's like half of parabola also, and from here there is a hole, and part of the graph is a solid dot here. And then the graph is continued from this point up to this point, and when it reaches this point we have a solid dot that we can see, and then another line that goes down and ended when x equals 3. So let us have the limit of f of x as x approaches 1. This is our x-axis. The number 1 value is here. So when x approaches 1, let us observe where is the height of the graph. We can see that the graph is coming to a point to that y value when x value is coming to 1. And when we consider the left side and the right side of 1, the graph is also coming to a single value, which is 1. So the answer here is 1. We can say that the limit of the function is the height of the graph, or y value, when x approaches the specific value. In this case, it is 1. Please note that the f of 1 equals 4. That is the point. Letter B, the limit of the function as x approaches 2. The number 2 value of x is here. Now let us observe the graph. It is coming to a value of y at this point, and the answer is 3. And we take note here the f of 2 is equal to 3. So these are the answers for example 1. Let us have example 2. Given the function y equals x squared minus x minus 6 all over x minus 3. Let us graph this function. The graph is a straight line, but there is a hole when x is equal to 3. Let us evaluate limit of the function as x approaches 1. Looking at the x-axis, the x value is here. And now let us observe what is the height of the graph when x is approaching 1. And the answer is 3. So we write here 3. We take note that the f of 1 is equal to 3. Letter B. The limit of the function as x approaches 3. Looking at the x-axis, number 3 is here. Let us check the y value when x is approaching number 3. And the answer is 5. In here, we take note also that f of 3 is not equal to 5. These are the answers for example 2. Hi everyone. Today we're going to study one-sided limits. We learned last time that this is the notation for limits. We read this as the limit of the function f of x as x approaches a equals the value L. To have a limit L as x approaches a function f must be defined on both sides of a, and its values f of x must approach L as x approaches a from either side. Because of this, ordinary limits are called two-sided. Let us now define one-sided limits. Suppose we want to find the limit of a function f of x to the right of the point A. The notation is this. The limit of f of x as x approaches a, and this a will have an exponent of positive sign. And we call this right-hand limit. Also, to find the limit of a function f of x to the left of the point A, this is the notation. Limit of f of x as x approaches a, and this a will appear like having an exponent of negative sign. We call this left-hand limit. Let us now consider the function y equals f of x represented by the graph. Let us now find the limit of the function f of x as x approaches 1 from the right. Let us locate 1 in the x-axis. Here it is. Again, we call this the right-hand limit. Now, when x approaches 1 from the right, the graph is approaching a value of y, and that is 1. So we write here 1 as the answer. Letter B, let us find the limit of f of x as x approaches 1 from the left. Again, we locate 1 in the x-axis, and we call this the left-hand limit. When x approaches 1 from the left, the graph is here and it is approaching a value which is 0 in the y-axis. So we write here 0. So these are the answers for the given limits. Now let us consider this theorem. A function f of x has a limit as x approaches a if and only if the limit of f of x as x approaches a from the right side exists and the value is L. Also, the limit of f of x as x approaches a from the left exists and the value is also L. In other words, the right-hand limit must be equal to the left-hand limit and the common value is L. In that case, we can say that the limit of the function f of x as x approaches a, this is now the two-sided limit, is also that same value which is L. Now, suppose the right-hand limit and the left-hand limit are not equal. So we say that the limit of f of x as x approaches a does not exist. In some books, you will see the symbol DNE. This means does not exist. Take note also that when the right-hand limit is not equal to the left-hand limit, don't write answer as 0. Again, what you're going to write is the word does not exist. Let's go back to our example a while ago. The right-hand limit is equal to 1, while the left-hand limit is equal to 0. So when we write the limit of f of x as x approaches 1, this is now a two-sided limit. As per our theorem, we can compare the values of the right-hand limit and the left-hand limit. We can see here that they are not equal. So the answer here does not exist. Let's have another example. Example D, limit of f of x as x approaches 2 from the right. Let us identify the number 2 in the x-axis, and it's here. The values are coming from the right. We can see that when x approaches 2, the graph is here and it is approaching a value of y which is equal to 1. So we write here 1. Next example, the limit of f of x as x approaches 2 from the left. So the number 2 is here. When x approaches 2 from the left, the graph approaches a y value which is 1. So we write here 1. Now, example F, the limit of f of x as x approaches 2. This time, this is a two-sided limit. So we will compare the values of the right-hand limit and the left-hand limit, and we can see that they are equal. And the value is 1. We will just simply copy this value and we will write it here. And that is the answer. Example G. The limit of the function f of x as x approaches 3 from the right. The number 3 is here, and we will consider those values of x that approaches 3. Then looking at our graph, it is now approaching a value of y, which is 2. So we write here 2. Example H is the limit of f of x as x approaches 3 from the left. So the number 3 is here. When x approaches 3, the graph is approaching a value of y, which is 2. So we write here 2. Example I, the limit of the function as x approaches 3. This is now a two-sided limit. And we can see here that the right-hand limit is equal to the left-hand limit. And the value is 2. So we will copy this and write it here. This is now our answer. Example J. The limit of f of x as x approaches 4 from the right side. So the 4 is here. When x approaches 4 from the right, from our example, the graph is not defined. So we write here, does not exist. Example K, the limit of f of x as x approaches 4 from the left side. So when x approaches 4, the graph is approaching a value of y, which is 1. So the answer here is 1. Now, example L. The limit of f of x as x approaches 4. We know that this is again a two-sided limit. Comparing the values of the right-hand limit and the left-hand limit, they are not equal. So in here, we will write does not exist. Example 2. Evaluate the limit of the function square root of x minus 2 over x minus 4 as x approaches 4 using a table of functional values. Note that x approaches 4. So we are going to write the table that looks like this. We have x here, f of x here, another set for x and f of x. This is one pair, this is another pair. For the first pair, with regard to the x, we're going to write values of x that comes to number 4 coming from left. So we write the values as 3.9, 3.99, 3.999, 3.9999, 3.99999. Given these values, we will solve for f of x. That means our function, here it is, the square root of x minus 2 over x minus 4. Let us find the corresponding values of f of x. For example, we want to get the value of f of x when x equals 3.9. That means we evaluate f of 3.9. So that will be the square root of 3.9 minus 2 all over 3.9 minus 4. We know that we change all x by the value 3.9. Using our calculator, the numerator is simplified as negative 0.0251582 all over negative 0.1 in the denominator. The quotient now is positive 0.251582 Then we copy this value in here. So, same pattern we will do for the other values of x. Then we can write now the values of f of x respectively. And here it is. Now for the second pair of x column and f of x. We write the values of x that comes to number 4 but coming from the right side. The values are 4.1, 4.01, 4.001, 4.0001, 4.00001. I hope you can see the pattern here. Now, let us find the corresponding values of f of x when x has these values. So, f of x will be like this. Now, for the first pair of x and f of x, we look at the f of x values. We can observe that when x values comes very near to 4 coming from left, the values of f of x will come to the value 0.25. So we can say that the limit of the square root of x minus 2 over x minus 4 as x approaches 4 from the left equals 0.25. Now what about the values that comes from the right? Looking at our f of x, as x comes to number 4 coming from the right, the values of f of x will come to the value 0.25. So we can write like this. The limit of square root of x minus 2 over x minus 4 as x approaches 4 from the right is equal to 0.25. Now let us get the value of the two-sided limit. So we write here, since the left side limit is equal to the right side limit, and both of them equal 0.25. Then the limit of the square root of x minus 2 over x minus 4 as x approaches 4 is equal to 0.25 also. Example 3. Given the function f of x equals x plus 1 as x is less than 2. Another function x squared minus 4 when x is more than or equal to 2. We have here three problems. Let's begin with the first one. The limit of the function as x approaches 2 from the left. Notice that we have here a piecewise function. Let us evaluate the limit from the left side. Now the question is, which of these two functions we're going to use? Take note that when we have here the less than symbol, that pertains to the left hand limit. While the more than symbol, it means that it pertains to the right hand limit function. Now, for the limit of f of x as x approaches 2 from the left, we're going to use this function x plus 1. So we rewrite our problem as the limit of x plus 1 as x approaches 2 from the left. Then we evaluate this. We substitute the number 2 to the x. So we have now 2 plus 1, which is equal to 3. This is the answer that we will write opposite the first problem. Let's go now to the second problem. Limit of the function x approaches 2 from the right. So we're going to use the second function. So we have now the limit of x squared minus 4, x approaches 2 from the right. We evaluate now this function. We substitute x by 2. So we have 2 squared minus 4. 2 squared is 4 and 4 minus 4 is 0. So the answer here is 0. Now let's go to the third, the two-sided limit. Limit of f of x as x approaches 2. From here, we need to compare the two values, the left-hand limit and the right-hand limit. We can see that they are not equal. So we write, since the left-hand limit is not equal to the right-hand limit, then the limit itself, or limit of f of x as x approaches 2, does not exist. Or to simplify, we may write D, and E. This is does not exist. So this is the answer for the third problem. Example 4. Using the diagram below, answer the questions. This is our graph that pertains to a single function. Number 1 question. The limit of the function f of x as x approaches -5 from the left. Here we have some clues on how to solve this. Number 1, look at x-axis and let us find as x approaches a. Meaning, in problem 1, x approaches -5. In the x-axis, -5 is somewhere here. And then step 2, we look at the graph. Meaning, this is the graph. We can have an imaginary vertical line here that passes through the -5. So, this is the corresponding graph that comes to this point when x comes closer to -5. Now, number 3, we look at the y value. That means the y value here is 2. So, the answer here is 2. Second problem. Limit of the function x approaches -5 from the right. So, step 1, the -5 is here. And then, the corresponding graph is here when x is coming close to -5. And then, we look for the y value, and that is same number 2. So, we write here 2. Then number 3, two-sided limit, the limit of f of x as x approaches -5. In this case, we compare the values of left-hand limit and the right-hand limit. We can see that they are equal. This is the same value for the two-sided limit. So we write here 2. Now, number 4, f of -5. -5 is here. On the graph, there is a point. Also, there is a line, but there is a hole at that point when x equals -5. That means we are going to get the value of this point when x equals -5, and that is 1. So, we write here 1. Number 5. Limit of the function as x approaches -2 from the left. -2 is here. The corresponding graph when x comes close to -2 is here. So, we will get the corresponding value as -1. So, the answer here is -1. Problem 6. Limit of the function as x approaches -2 from the right. So, the -2 is here. The graph will be this graph. And when we have an imaginary vertical line that passes through -2, this is the corresponding graph when x comes closer to -2. Then we find the y value, and that will be 4. So we write here 4. Number 7. This is a two-sided limit. So simply we compare the values for left-hand limit and the right-hand limit. We can see that they are not equal. In that case, we conclude that the limit itself does not exist. Problem 8. F of -2. This means what is the exact y value of the function when x equals -2. So on the graph, the -2 is here. Here we can see a solid dot. That is a point, and the y value is 2. So we write here 2.